Let's look at this example right now. It's 8x minus 15 equals 49. Now this is a little bit more involved than what we've done before. All the problems that we did earlier, one step and you were done, right? You either added something or you subtracted it or you multiplied or you divided it, and that was it. You were finished. This time, you're going to have to do more than one step because there's more than one thing going on with this x right here. It's not just being multiplied by one number. It's not just being subtracted from by one number, okay? A couple things are going on here. First of all, look, this is being multiplied by 8, and you're also subtracting a 15 from this, aren't you? First thing you want to get rid of, what's being added or subtracted. Whatever's being added or subtracted from it, that's what you want to get rid of first. Then you can get rid of what's being multiplied or divided. It's kind of like the opposite of, remember the My Dear Aunt Sally thing, order of operations? It's kind of like the opposite of that. All right, so usually you do multiplication first, right? Then you do addition and subtraction. This time, we get rid of what's being added or subtracted. Then we can get rid of what's being multiplied or divided. You got that? So let's do it. What's being added or subtracted to this x? The 15. Okay, it's a minus 15. How do we get rid of a minus 15? We add a 15 to both sides. That adds up to 0 or cancels out. Bring down the 8x. And you add that up. That's a 4, that's a 5, that's a 64. Everybody see that? It's just a simple little step, but it's the same problem. Now we got another step to do, though, don't we? Because x is still not by itself. How do we get rid of this 8 right here? Divide by 8, right? Divide both sides by 8. It's the same thing as we did earlier. That cancels out. X is, what's 64 divided by 8? 8. And there it is. There's your answer. Showed the problem, showed all my steps, and then showed the answer. Let's go on to the next one. This one's a little bit different, but with some similarities. All right, that's supposed to be an equal sign right there. All right, so 12y plus 8 equals 6y minus 5. What's different about this compared to what we had right here? There's two y's. That's right. There's two variables, one on one side, one on the other side. So what we want to do is get those y's on the same side. Again, you've done this before, haven't you, in Algebra 1? There's two ways of thinking about this. Some people always like the variable on the left-hand side no matter what. I kind of prefer to put the variable on the side that makes it positive. All right? In this particular problem, both ways is going to be on the left-hand side. I would like to get rid of the 6y. Now look, I'm not just getting rid of the 6. I'm getting rid of this whole term right here. So I have to think of that as just one number. All right, just think of that as one number. What is that one number doing to this other stuff over here? Well, it's being added, right? Or this is being subtracted from this, or this is being added to this. So this is a positive 6y. How do I get rid of a positive 6y? I subtract a 6y. Then I come over here and I subtract a 6y from this. Make sure you don't subtract it from the 8 because you wouldn't be able to subtract it from 8, would you? You can only subtract y's and y's from each other, like terms. Remember that? Okay, so I'm going to put a little line underneath it here. Look what happened to that 6y. That went away, didn't it? Added up to 0. Now look, in the same step, I'm going to get rid of this 8. I'm not going to bring everything down just yet. I'm going to get rid of this 8 right now. This is a plus 8. How do I get rid of this plus 8? Subtract 8, and then I subtract an 8 from the other side. And look what happens. That adds up to 0 or cancels out. And now I can subtract all my stuff. 12y minus 6y is just 6y. Negative 5 minus 8. Here's that one that's a little tricky for people sometimes. Right, you add the opposite. Negative 5 plus negative 8 is negative. You add them up, right? Because they're different signs. They're both the same sign, aren't they? Both negatives, and you're adding, so you keep the sign, you add them up. So it's negative what? 13, okay? And now you get rid of the 6 by dividing both sides by 6. We've seen this a couple times already. That cancels out. And look, your answer is just negative 13 over 6. There's no reason to change that into a mixed number or a decimal. Just keep it improper, just keep it like that, and that's your final answer. Does it make any sense? All right, we got one more to do. There's just no reason. There's no reason to, some people say, and I've heard teachers say this, they say, oh, you have to simplify this. Well, that's simplified. Or some people say, you need to reduce this. Well, sure, you do need to reduce your fractions, but can you reduce this? Is there something that goes into 13 and 6? No. All right? Changing this into a mixed number is not reducing it. All right? I've heard students say that, and I've heard teachers say that before. And that's not true. All right, that's not reducing it. You're just changing the form of it. This is fine, just like this. Because look, what happens? You're like, okay, what is that? That's like, I don't know, 1 and 1/6 or something. You're like, well, wait a minute, that's not right. What is it? Oh, it's 2 and a 6. And then you forget the negative. See how many situations you could mess up with? All right, I mean, that's right. I wouldn't mark that wrong if you wrote it like that. All right, but why take the chance? Why take the chance of going from here to here and messing it up when that's your answer right there? Now, if you were doing a word problem and they talked about the lengths of something, I mean, 13/6, that doesn't really make sense to us if I talk about how long something is it? Okay, if I say measure that wall right there, well, it's 13 over 6 feet. That makes no sense. You would say what? 2 and 1/6, wouldn't you? But if it's just a regular old math problem, just keep it improper and don't mess with it and go on to the next one. That's what I would do if I were you. But as many times as I say that, people are just so intent on changing it. They don't like seeing that improper because teachers in the past probably have really gotten on your case about keeping them improper. I bet you your teachers back when you were a kid in elementary or middle school probably always made you change it to a mixed number like this. All right. Well, you don't necessarily have to. In algebra, sometimes keeping it improper is better. Sometimes. All right. So we're just going to keep it improper. One more. All right, this is a little bit different looking. You only have one x here, all right, so it kind of looks like what we did up here, but we hadn't seen this parentheses before. What's up with that parentheses? What's going on? That's right, distribute. Good, you know that word. So you distribute the 3 through both of these. It's a multiplication, so you're just taking that 3, multiplying it by everything in the parentheses. It's called distributive property. So let's do that. 3x, what? Minus 15. Don't forget to take it through the second one as well. A lot of people tend to forget that. They'll see the first one, they forget the second one. All right, equals 13. Now, this problem is almost identical to this one up here that we did. All right, so we shouldn't have a problem with this. Let's just do it real quick. Add a 15 to both sides. That 15 cancels out. Bring down the 3x. And that's what, 28? Divide both sides by 3. And that's your answer. Just x equals 28 over 3. Now, always look to see if that reduces. Does 3 go into 28? No, it doesn't. Not evenly. All right, so I just don't mess with it. There's no real reason to change this into a mixed number unless they tell you, and I don't think they're going to tell you. All right, so I would just keep it improper and bang. There. Oh, that was a big old check sign, wasn't it? Didn't mean, that's a little bit better. All right, there you go. So that's it, and that's your answer. Just keep it like that. Do you see how I'm doing these problems? I write down the problem, show my steps, show my answer. You should be doing that for each one of these. All right, any questions real quick on this stuff? If you need to review it, if you see some problems on here, you weren't quite sure about it, go back tonight, okay, go to the YouTube site, and you'll be able to find it and be good to go. Today, I'm going to give you a worksheet today, but I'm going to take it a little bit easy on you. And you only have to do the evens, okay, on this section 05. You only have to do the evens. Tomorrow I'm going to have you do the odds, so you will eventually have them all done, okay? But I'm splitting them up into today and tomorrow. Have a seat. So it's evens, just the evens, all right? Yeah. Yes, go ahead.